Our unfathomable lead is way out of this world, 390 light-years away. Truth be told, for setting, 1 light-year is undefined from 6 trillion miles. In mankind's resolved mission for relaxing the secrets of the universe, we've set off on an excursion that goes past time itself, looking for replies to progress in years-old solicitations woven into the outer layer of presence. The James Webb Space Telescope, with its unblinking eye, has actually perceived a short look at a design originating before the show of stars. This glorious thing had all the earmarks of being more antiquated than the actual universe, raising more inquiries than it responds to. How should a structure exist that begins before our universe? Or is the speculation of how things became to fault? Go along with us as we set out on an odyssey coordinated by the revelations of the James Webb Telescope, where the privileged insights of a 13.8 billion-year-old universe anticipate. Moreover, the excursion to unravel these huge secrets has started in a far-off corner, only very narrowly, of the universe, around 200 light-years away. An old star called HD 11114283 dwells close to the Libra star grouping. This superb explorer moves vivaciously through space, offering brief impressions into its fierce past. Unequivocally, quite a while back, when our Milky Way was still in its early stages, it consumed a dwarf world that once called it home. Yet, what genuinely piques our enormous interest in HD 11114283 isn't simply its quick cycle. It's its amazing age. Among the heavenly elements we've seen, it remains one of the most established, earning the captivating moniker Methuselah star, contrasted with the scriptural figure Methuselah, who legend has it lived for a considerable length of time. At first estimated to be a stunning 16 billion years old, the most recent evaluations suggest a somewhat more youthful time of 14.46 billion years, with a wiggle room of 0.8 billion years. This disclosure about its age frustrated space experts, as the age of the universe, determined from the Cosmic Microwave Foundation, floats around 13.8 billion years. This issue brought up significant issues about the star's age, the universe's age, and, surprisingly, the exactness of our dating strategies. We should separate it. Sorting out the period of extraordinary items can be a genuine test. Take stars, for example, like the sun. They're likened to ageless lights, keeping up with their brilliance, temperature, and size for billions of years, making them captivating to mature. To date, space researchers use changes in splendor and variety as signs, consolidating these with models for seeing how stars advance over the long haul. One age giveaway is how rapidly a star turns. Like a wheel easing back down over the long haul, stars do this too. By looking at the rotational velocities of stars at various ages, space experts have sorted out a shrewd trick called gyrochronology. Stars likewise spill their age mysteries through attractive gab, flares, and outflows of energy on a star's surface. Cosmologists, being the space specialists they are, utilize progressed strategies like astroseismology. It's like listening in on a star's inner discussions, zeroing in on vibrations brought about by waves going through its interior. These vibrations reveal the star's age. For example, applying this infinite sneaking around, space researchers pegged the sun at 4.58 billion years. Now back to Methuselah star. The old radiation around it isn't simply conflicting. Space researchers labeled it with an old age by really looking at its infinite metal substance. Stars can be characterized into bunches based on how much bling or heavy elements like iron they have. Our sun is relatively a metalhead, belonging to population 1 stars. Methuselah star, on the other hand, resembles an old remnant from population 2, shaking fewer heavy elements. This cosmic fingerprint makes a difference. Space experts play cosmic archaeologists, unwinding the age accounts of these divine bodies. Currently, imagine a get-together of stars population 3, which examiners accept might be the universe's most unprecedented jewels. While they're still concealing behind the scenes and haven't yet showed up in our telescope spotlight, stargazers suspect these stars might be the legends of creation, containing practically no heavy elements. To comprehend the well-conceived plan, we need to rewind to the universe's early days after the Big Bang. Picture an interminable kitchen filled generally with hydrogen and helium, the universe's fundamental fixings. Around 92% hydrogen and 8% helium, or assuming we weigh them around 75% hydrogen and 25% helium. In this vast ensemble, the main entertainers were the population 3 stars. They were colossal and hot, burning their fuel quickly, changing hydrogen and helium into heavier elements. When these early cosmic monsters detonated, they spread these heavy elements into the vast region. In line were the population 2 stars, forming a piece later but still in the universe's early days. Their unique materials were stacked with heavy elements, especially iron. Many of them carried on with their heavenly life cycles, detonating into supernovae and adding more heavy elements to the general mix. Finally, the population 1 stars, including our Sun, emerged as cosmic rebels, forming from advanced gas clouds mixed with remnants from the earlier population 2 stars. Now the focal question. Does this grand story throw a massive curve at the theory of the old Big Bang? It's a head-scratcher. But here's the twist. There's a 70% chance that Methuselah's star, the old cosmic drifter, could be in the area. There's a 13.66% chance that this ancient heavenly vagabond's age is playing outside the cosmic rulebook. Similarly, there's a 15% chance it's not quite as old but much younger. Imagine rolling a standard 6-sided die and anticipating one of 6 genuinely potential results. Despite what these infinite bends toss at us, one thing is certain. Methuselah's star isn't just a giant veteran. It's the granddaddy of stars. We've figured out how to give it an age name that's extraordinarily precise. Now here's where it gets fascinating. Rather than scratching our heads about whether Methuselah's star could be 2 or 3 billion years older than its cosmic neighbors, we should flip the cosmic script. Imagine a scenario where the actual universe isn't as young as we once thought. Consider trying to figure out the immensity of space itself. If we turn the entire history of the universe into a cosmic calendar, with the Big Bang as the most amazing New Year's fireworks, Earth wouldn't join the grand cosmic party until the last seconds of December 31st, human recorded history. That's just a blip in time, covering only the last 10 seconds. Our infinite specialists decided the universe's age by looking at old starlight, born a few 100 million years after the Big Bang. As the universe expands, it gives this light a tremendous makeover known as redshift. By crunching the numbers on both distance and development, researchers declared a general age of 13.8 billion years. But hang on. Since the cosmic situation starts to get captivating, a boundless pondering from the University of Ottawa suggests the universe might be an incredible 26.7 billion years old. Professor Rajendra Gupta presents an intriguing hypothesis from 1929 made by Swiss cosmologist Fritz Zwicky, and it's stirring up our cosmic thinking. This hypothesis complicates matters, suggesting that as light particles, photons, cross the vastness of space, they lose a portion of their energy over time. However, this idea doesn't perfectly align with what we've seen through our telescopes. Gupta proposes a cosmic compromise. He suggests we can blend this hypothesis with our current understanding of a growing universe, creating a hybrid explanation for the redshift phenomenon. Now, fasten your seatbelts. Changing the universe's age to an astonishing 26.7 billion years is no small feat. Gupta adds another twist to the cosmic mix by combining the photon light hypothesis with evolving coupling constants, a brainchild of theoretical physicist Paul Dirac. This idea suggests that how particles interact may have changed over time. And hey, scientists have a history of tweaking the cosmic clock. During the 1920s, Edwin Hubble thought the universe was a simple 2 billion years old. We've come a long way since then, refining our cosmic math and multiplying the universe's age. It's like taking a giant leap in our vast vision. But we should pause for a moment. Whether this new perspective becomes the cosmic norm is still up in the stars. Paying little mind to whether humanity's recorded history is a mere blip of 10 or 5 seconds in the grand scheme of the universe. One thing is clear. The universe is a treasure trove of ancient wonders and endless inspiration. Looking to our galactic backyard, the Milky Way, there's a dazzling cosmic tango at play. Later estimates hint that stars on the edges of our galaxy are strutting their stuff in slow motion compared to their partners in other galaxies. What's the cosmic scoop? Well, there are a few theories. One consideration is that our Milky Way may be running low on an invisible cosmic ingredient called dark matter. This mysterious substance affects the gravitational dance of massive objects. There's an endless question involving dark matter, the elusive substance we can't see but seems to play a gravitational push and pull in the universe. One possibility shaking our grand understanding is that perhaps we've been measuring dark matter wrong. Our universal compass could be pointing off course. Here's where the European Space Agency's Gaia satellite steps into the cosmic spotlight. It's like our vast expert, offering intricate insights into the dance of nearly 2 billion stars in our Milky Way. Think of it as a gigantic advancement test. The satellite's precise measurements have led astronomers to rethink their grand cosmic notes. Stars at the outer edges of our Milky Way seem to be moving slowly, challenging our old assumptions about their speeds. How do star speeds spill the cosmic beans about a universe's makeup? It's like measuring the size of a gathering by how fast people are moving. Armed with Gaia's data, space researchers estimated the combined mass of our galaxy's gas, dust, stars, and that elusive dark matter to be around 200 billion times the mass of our sun. It sounds like a cosmic heavyweight, but here's the twist. It's several times less than we previously figured.